It's a good thing we didn't forget the camera, right? What's up, everyone? This is The Bridge. I'm Adrian, and for those of you who are new to this channel, here at The Bridge, we're creating an interdisciplinary bridge for scientific ideas so that you guys can engineer across disciplines for a better future. Today, we're interviewing an organization here at UIUC called the Illinois Space Society. The Illinois Space Society competes in many different competitions, some of which even include NASA competitions. At these competitions, they sometimes even work hand in hand with NASA astronauts to develop the tools they could potentially use someday in space. This is all pretty damn exciting, and I think you guys will be pretty interested, so let's go check it out.
There was an idea to bring together a group of remarkable engineers to see if we could become something more. So when they needed us, we could build the rockets that they never could.
Hi, I'm Courtney. I am currently the admin director of the Illinois Space Society, and I'm also the safety officer for the technical projects.
My name is Christine Mayer, and I'm the assistant director of ISS.
How's it going? I'm Charlie. I'm the team lead of Illinois Space Society Space Grant.
My name is Shivani Ganesh. I'm currently the educational outreach director for the Illinois Space Society.
My name is Tiger, and I am the project manager for the RASCO competition, which stands for the Revolutionary Aerospace Systems Concepts Academic Linkage. It's a NIA competition, and NIA is hosting this on behalf of NASA.
So my name is Brian Hardy. I'm currently the propulsion and trajectory sub-team lead for RASCO, one of the tech projects. And besides that, just an active member, work, all the social stuff and everything that comes with that.
I'm Jake Hawkins, and right now I'm the structures sub-team lead for RASCO, and then I'm on the avionics, payload, and structures team for IREC.
I'm Erica, and I'm the SEDS representative on the ISS Executive Board.
I'm Karna Patel, and currently I don't have any actual executive standing in ISS, but I'm a pretty active member, currently in Space Grant and Micro G.
What projects have you been involved in the past?
So I have been a part of the hybrid rocket engine project for 3 years. I started my freshman year as just a team member working on injectors. And then the sophomore year, I actually became the team lead of it, which was a really exciting role for me. I loved every second. And now I'm more focused on educational outreach and professional development events.
Last year I did Space Grant.
So besides educational outreach, I was a project manager of the NASA Space Grant team last year. It's an all-freshman team that works with the Midwest High Power Rocketry Competition to accomplish a challenge and build a high-power rocket that we get to see launch at the end of the year.
Well, during my freshman year, I was the avionics and payload subteam lead for Space Grant. So we built a roll-controlled rocket, and what me and my team did is we designed the avionics bay, and we also implemented a feedback roll control system that was able to control the rocket. In the past, I also did student launch, which is now replaced with IREC, but student launch was basically launching a huge rocket in somewhere in the middle of the US. That was pretty fun. I was a member on that team. We helped build the rocket airframe and stuff. And this year, I'm just doing Rascal.
And what projects have you been involved in the past, ISS?
That's going to be a long answer. So I started in ISS when I was a freshman 5 years ago. Actually, 4 years ago, my freshman year, I started in ISS. And I was pretty involved the first 2 years. I worked on Rascal my freshman year, so this is like my return to it since then. I worked on NASA Student Launch, which is a high-power rocketry competition that we used to do. Now we've transitioned to IREC. Worked on a couple different other projects, studied abroad my sophomore year, and then when I came back, I really dove into being on the executive board. I was elected as tech director, so I worked in that role all junior year and was pretty much involved in every tech project. We had 6 or 7 that year, so it was a pretty full-time job, it felt like sometimes. And then senior year, so last year I was the director, so now I led the whole society, executive board, and everything that entailed.
Previous projects I've been involved with is the NASA Micro-G Next Challenge. I've also been involved in Rascal, which is a student kind of theoretical design competition, student launch, as well as the high altitude balloon pilot projects that we did for 2 years.
And can you break down what the different subgroups are in ISS?
So we kind of have 3 pillars, I would say. There's educational outreach, professional development, and the technical projects. And all 3 are really kind of what makes ISS a club that's so unique. If you just have the technical projects, yes, you're technically advanced, but you have no kind of people skills to offer to companies, where I think Illinois Space Society does a wonderful job of making you not only just a better person in the workforce, but just as a member of society, in a sense.
And could you explain a little bit about the competition Space Grant is doing this year?
Yeah, so this year's really exciting. We're going supersonic, baby! Yeah, so we're going to go above the speed of sound. Right now we're at 1.17 according to Open Rocket, or the software that simulates our rocket designs. And we want to make it efficiently supersonic. So not just go above Mach 1, but we want to make it with the lowest altitude, lowest thrust, or how much power the motor has, and lowest impulse, which is the area under the thrust versus time curve.
So could you talk a little bit about why the Rascal competition is so important, and kind of about the different design choices that go into that competition?
Mm-hmm. Yeah, I think I want to start with kind of outlining how unique Rascal is as compared to the other ISS projects. Because Illinois Space Society, right, we have a bunch of hands-on projects. All our projects involve some sort of design, manufacturing, and building. But Rascal is unique in that it is entirely theoretical, first of all. But at the same time, it kind of brings out like a different facet of like the entire aerospace thing as a concept. I think Rascal is important because you can have good engineers, but what the engineers also need is kind of like a vision to guide them. If you want to build a rocket, you have to have a vision of what this rocket does. If you, for example, Micro-G, you want to design a tool, you have to have a mission that kind of outlines what you're going to do and design accordingly. So Rascal is kind of this design and outlining process where you get a request for some sort of mission and then you design around it. You leave the actual like manufacturing and engineering construction part out of the equation, but what you have the freedom to do is envision how this whole mission is going to play out and really look at it from a more high level and systematic perspective. So for example, this year, what we're doing is designing a crewed reusable lunar lander. So that requires us to first kind of figure out what our mission parameters are. So we're going to land on the moon. We're going to have to use the NASA proposed Gateway space station. And the rest is up to our imagination. So there's a lot of kind of like free moving parts you have to coordinate. And I think sometimes looking at the bigger picture is very important, and being able to draw in new technology, merge it with old concepts, and then turning that into a new thing is something that is very important. That's why Rascal stands out and is unique and important to me.
Can you talk a little bit about how IREC is structured?
Yeah, so there's a bunch of different competition categories. The one that we're doing this year is the 10,000 foot hybrid rocket engine competition. So, each team makes their own hybrid engine, which is just like a solid propellant with a gaseous. So we've got like paraffin and NOS. And the objective is for the rocket to go to 10,000 feet. And then there's also a payload in the rocket that will do something. But IREC isn't picky about what it will do.
You've previously been involved in Micro-G. Could you talk a little bit about what this project is?
I would say Micro-G, compared to the rest of Illinois Space Society tech projects, is really the hands-on design, manufacture, and test of something that could potentially end up being used by astronauts in space. So I guess the unique thing about my Micro-G experience is we've had kind of two different seasons, or two different kind of challenge requirements. So the anchoring device was to be used kind of for that presidential decision for NASA direction, to be used kind of as something to anchor your payloads, anchor astronauts, whatever would be useful to kind of bolt something down on a surface where we don't know what the gravity's like. But later, kind of as that missions kind of no longer became part of our goals for the NASA program, it turned into more of the use of International Space Station. In my second year, one of the major problems on the International Space Station is a micrometeorite orbit debris, or MMOD. So our job was to define some type of sealing device that would be able to then repressurize an airlock on the International Space Station.
And so when you guys design this device, what typically happens? Is it just all theoretical, or do you go ahead and build it? What's kind of the process you go through?
So we do everything from the initial brainstorming, then we move on to CADing and 3D printing the part, and then we actually go to a lot of times to the machine shop where we have them make the parts for us, and then we go and test them kind of in local pools to kind of give the experience of microgravity. And then hopefully we bring them down. Once we're selected, we go down to Johnson Space Center and we test our tools in the neutral buoyancy lab, where we ourselves as students are directing astronauts and astronaut divers to use our devices. And I think that's something I was never able to find besides in Micro-G.
And what types of different opportunities does ISS offer for professional development?
So ISS actually offers a plentiful amount of professional development opportunities. So pretty much the foremost event that we do is the Von Braun Symposium. At this event, we bring 10 to 15 students all the way to Huntsville, Alabama, where they can go ahead and talk to the director of NASA, multiple industry leaders, about what it's like being an actual aerospace engineer and what are the challenges and opportunities that people face in these roles. It's definitely one of the things that people look forward to the most, and you also get to hear about all the new technologies and areas in aerospace engineering.
And what is it like to represent so many freshmen on the executive board?
The freshman class this year particularly, I think, are a group of really successful and knowledgeable people. And I'm really excited to get to know all of them and to see how far we can take this club.
And what do you do in your role on the board?
So I go to the monthly National SEDS meetings, which are online. And SEDS stands for the Students for Exploration and Development of Space. And so ISS is a chapter of that national organization, and I just kind of relay information between the two groups.
Can you talk a little bit about how IREC is structured or broken down into teams?
So yeah, there's the structures team handles the overall structure of the body, like what kind of material is used for the body tube, what size the body tube is, what type of nose cone we're using. We're using a thrust plate this year instead of having the fins epoxied to a motor mount tube in the middle. So those are all structures decisions. And then avionics is responsible for all the making sure the parachutes deploy correctly, having all the electronics wired up. Specifically, with since we're using our own motor this year, there's also going to be integration with the propulsion team, making sure it's reading data from the engine correctly. And so there's a few avionics bays throughout the rocket to handle each of these things. And then they're also doing drag control, because you get more points the closer you are to 10,000 feet. So it's important to have some sort of active drag to make sure we can get as close as possible. And then the payload team is in charge of creating the payload that will go in the top of the rocket. That's not as integrated into the design, except for the fact that we have to work with structures, make sure it actually fit. But it's more free form and not as dependent on everything else.
Charlie, what surprised you most about spacecraft?
I think what surprised me most is the fact that we're an all-freshman team, and we didn't learn any of this from an aerospace class or even our chemistry or math class, but we actually learned it all from researching online ourselves and a couple rocket mentors. And the fact that we're able to build such a complicated rocket that's almost unheard of for somebody in their first year of rocketry is really amazing.
Okay, and so the IREC competition has obviously been going on quite a few years. Mm-hmm. And although you've been involved only a year, I take it you've had quite a bit of experience working on this project. What do you think makes ISS specifically so competitive in the IREC competition?
I think it's our willingness to do as much as possible. Our payload this year is we're going to deploy it aerially, and then it's also going to be able to turn, whereas last year's rover wasn't able to turn. And then it's also going to have cameras on it, so we're going to try to do object avoidance on it. And I think any one of those objectives. Oh, and it's also going to deploy solar panels. So any one of those objectives would probably be more than enough for an IREC team to do something to take on for the year. But we decided to do all four.
So that whole thing sounds pretty imagination plus learning plus speculation and of course a lot of real scientific values inside. How would you say the percentage is between the couple imagination versus scientific truth?
I would say scientific truth takes up 80% at least, because you can't just say, oh, we're gonna have a dark matter engine in the next 5 years, right? So engineering and reality takes precedence over imagination. What is imaginative isn't necessarily what your vision of the future technology can be, but instead what I think at least the organization's goal is for us to use our imagination to combine new technology with old concepts and new things in new ways, so that you enable previously impossible architectures. So for example, the engine that we're using in our design is a variant of the RL-10, which is a super efficient liquid oxygen, liquid hydrogen engine. And that is what enables us to reuse this entire vehicle multiple times, because during the Apollo era, it was impossible to reuse those hypergolic engines due to the corrosiveness of all the materials and the fuels. So it's more about imagining how new technology can enable new systems rather than imagining what the future technologies can hold for us.
What ISS accomplishment do you think you are most proud of?
Well, for Rascal, recently we submitted our abstract, which is getting into the first round of the competition, and we just got the results back. And we not only did we get in, but usually the judges give feedback. And this year they told us that we had done so well that they didn't really have any feedback to give us. And a lot of the upperclassmen who had done Rascal in the past, they were surprised that was even a thing. So I felt very proud to be a part of that.
So Charlie, how do you go about creating an effective team?
Yeah, so I think the biggest key in an effective team is just bonding. So in the beginning of the year, we had some nice Frisbee matches, we had ice skating, we had a bunch of team bonding experiences that don't have to do a space grant. We go out to dinner all the time. Don't worry, engineering isn't 100% the grind. You still have some fun in there. But that's why I think our team really does well together, is because we really get to know each other. Even Jeffrey and Adrian probably met each other on space grant, which is why our team has such great bonding and great dynamics together. So it's really about how well you do outside of the meetings and how well people know each other outside of the meetings, how much fun people have. And if everyone's having a good time, it's really hard to get that frown. It's really hard to keep that frown on your face. So that's a really fun part of space grant.
So with so much leadership experience, you've obviously gathered probably some like leadership styles or skills that you specifically prefer to use. What is kind of your leadership style or the way that you approach leading your group or sub-team?
So I would say, the members on your team, the people who are, with you day in, day out, and like, they're working their hardest, they care, never overly criticize them when they make a mistake. Because generally people who, you trust and who are on your team, like they know when they made a mistake and like they already feel bad enough about it. And, I heard a quote once, it's like, no one ever changed their mind because they were, publicly humiliated for like a mistake. It's like, if you ever call someone out on something they did in a very public way, that just entrenches people, into a corner, and that's not good for the team mentality. So I think the biggest thing is, when someone makes a mistake, which, it happens for sure. I think the key is to, if you have criticisms, those need to be private and not a club-wide declaration or anything. And it needs to be constructive criticism. You can't just say, hey, this was bad. It needs to be about solving the problem and not just hammering in that, like, hey, you screwed up. So I'd say that's the biggest thing, because ultimately it's like, it's keeping the team working together is like the biggest challenge, I would say.
What would you say is the kind of key to this team-to-team interaction? What basically makes this successful?
I think constant communication is essential. And I think the Aero Lab where we all hang out is pretty, essential to that, because even though we're not like having meetings, we're all there doing homework. So, if one of the sub-team leads needs another sub-team lead, they can just walk over and ask them. So it makes, there's relatively low barriers to communication.
What skills have you developed as part of these projects that you think will be most helpful to you, not just necessarily in aerospace, but in other aspects of your life?
Mm-hmm. So I think you can divide this into two parts. The first part is the technical skills. So obviously there's going to be a lot of analysis. So these are your software tools. For example, modeling, we use NX. Thermal simulations and stress simulations, we use ANSYS. And there's a bunch of trajectory calculations, which we use GMAT, which is the General Mission Analysis tool. And finally, we also use Python and MATLAB to do a bunch of the other fuel, radiation, and miscellaneous calculations to really design the mission. So you really get a whole array of software that you can kind of master. Maybe not all with one person, but as a team, you gain these skills. And on top of that, some more soft technical skills would be like just your ability to analyze these systems and come up with ways to compare them and do these trades. So that's technical. And apart from that, there's also kind of the non-technical parts, which are going to be like your writing skills, your research skills, the rigorousness of your writing, and a bunch of these different things, which really don't count as anything in particular, but really helps you convey your ideas and makes your entire research more sound. So I think apart from the technical skills, I think these soft, like non-technical skills might even be more important, because a lot of engineering is just about how to convey your ideas clearly and how to write them out. So I think that's something people learn a lot as well.
And in terms of professional development, when you go to these symposiums, you meet a lot of these very important people. Do relationships get founded there that then could potentially lay the foundation for the rest of your career?
Yeah, so actually my freshman year, we went to a symposium in Washington, D.C. called the Goddard Memorial Symposium. And at that symposium, I met a man named Joe Rice, who was actually a governor at Colorado at one point and currently works in project management at Lockheed Martin. And going in there as a freshman, I didn't know if engineering was right for me at all. And after talking with him, I learned that you can kind of combine engineering with business. And ever since then, that's what I had my sights on. I've stayed in contact with him all the way through senior year. He's helped me along the way, and I can positively say that I would not be doing the career I am now if it wasn't for me talking to him initially at the symposium.
What do you love most about ISS?
The people. That sounds very cheesy, but ISS is quite literally my family on campus, and I love connecting with the seniors and upperclassmen and seeing how much ISS has impacted their lives, and seeing new freshmen come in this year and grow the same way that I did freshman year because of the club. It's wonderful, and I really hope the club always contributes that to its members.
And what is it like to be a freshman in such a pretty successful club?
Honestly, it's actually pretty intimidating. I see that a lot of the seniors and upperclassmen have done a lot of work, and it's really praiseworthy, and I feel like I have to, right now I look up to them and I feel like I have to be in their shoes one day, and it's really scary. But it's also really fun. I hope to move up the ranks in ISS and maybe become, hopefully, like a project lead or something. I feel like that'd be really fun. That get me much more involved in the club. So that's where I'd like to be.
And what does it feel like to be like a woman in engineering? Like, is it empowering? Is it like a lot of fun, a lot of curiosity, something like that? Like, just talk about it.
Yeah. So when I first started out in engineering, I was so nervous about being a female because you always hear kind of horror stories. And so I walked in and I got a little more nervous as time went on, but then I kind of found ISS. And I have never experienced any animosity because of my gender through ISS. We are truly just all here for each other. So based off of that, I'm just empowered, and I don't feel different at all because I'm a female. I just feel like I should go ahead and spread the word so that way more females get into this field.
What would you say were like kind of your expectations when you were joining ISS versus what it turned out to be and what it has evolved into today?
I would say even in the past 2 years, we've grown. I don't know if I mentioned I'm a junior in aerospace, and I came in as like a freshman. I would say like amount of knowledge and of kind of the history ISS has grown in these past 2 years. Winning, placing at Space Grant, kind of making a name for ourselves where the divers have told us, oh, your tool was like the tool of the week. It was well designed. And also like educational outreach, people are continually asking us to come back and teach our school because they love the events we put on. I think it's really allowed us to kind of see where we've come to where we're going, and I cannot wait to see what we achieve in these next 2 years.
How would you say that ISS has impacted you the most?
Oh my goodness, it's given me purpose to keep doing this major. So when I came into college, I was very wary about doing aerospace engineering just because I always thought I was going to be a physics major doing research, whatnot, not really contributing to any other realm of STEM. And I can guarantee that I have had a million falls and constantly questions whether or not I really love doing this. But then I'll go to like a liquid nitrogen demo at a preschool, or we'll talk to kids at an FLL competition, and the way they ask questions, the way they're engaged, that's exactly why I want to pursue space exploration. And interacting with these kids really reminds me of why I chose it and why I need to keep pushing forward.
So where do you see yourself in 5 years?
So currently in the summer, I'm going to be a flight test engineer for Boeing. And through their program, I hope to get my master's degree within 2 years in aerospace engineering, then my MBA in 5 years. And hopefully around that time, I will work my way from flight test engineering to project management in Washington, D.C. But life changes, as it always does. So I'm just really excited for the journey and all the opportunities that come from it.
Sounds exciting.
Yeah, I'm really excited.
Where do you see yourself in the next 10 years?
All right, future. So in the next 10 years, I really hope to see myself kind of leading people, but also working with them. I really like human factors. I like working with people. It's, kind of where I've been involved with for Illinois Space Society as the safety officer, environmental control and life support systems. Really is where I'd like to see myself. So at NASA, of course, Johnson Space Center would be amazing, but also now with the exposure of commercial space flight, kind of maybe helping build their side of human factors would be a very unique experience.
So you talked a little bit about the commercialization of space, and where do you see this industry really evolving and going in the future?
I think really driving partnership with the government and the commercialization is really what I'm excited to see for in these next 5 to 10 years. Kind of when I was growing up, it was more of just like, oh, it's like NASA, the United States Air Force, not really many other major players that I had known of, but now it's SpaceX, Blue Origin, Aerospace Corporation. You have all these different players and all specialize in different things, and you're really able to kind of find what you like in a sense, but also doing it in a unique and hopefully safe way. And I think that's another thing I'm very excited for with the commercialization, is how we're going to break bounds using previous kind of technology, but also being able to expand the limits. I think will be a very unique thing to see in the next 10 years, and I'm very excited to be a part of it.
As you guys can see, ISS is an awesome club here at UIUC. They're working on competitions, working with NASA, and having a great time with friends at college. If you guys liked what you saw, go ahead and hit that like button, smash that subscribe button, and let us know below if you've got companies, organizations, projects that you'd like to see in upcoming videos.